Hey folks, join me for Networking 101 when you'll figure out what the heck we use this thing for. You know, if there ever was a Rodney Dangerfield of networking, it's probably the physical layer, right? When we're studying networking, physical layer is one of those things that is the very last letter in a mnemonic that we all memorize when we're trying to learn the OSI model, right? For setting it up, right? So you all remember the mnemonic, right? It goes, let me click on my pen here, all people seem to need data processing. It's a way that we use to represent, you know, layers, oops, not layer 1, but actually layer 7 to 1 down here. And physical layer, it's on the bottom, doesn't get any love. You know, a lot of people just say, well, physical layer, that's a hardware aspect of it, right? That's just, you know, that's your cables, you know, that's your interface here. That's what that piece of it is. But man, physical layer, it's so much more, right? So we're going to cover a little bit about some of the, it's my favorite layer. It's the most amazing one. And let me show you why. Networking folks tend to divide their careers up and down this same spectrum, right? So no matter what your career is, you can pretty much map it to the OSI model. If you are a route switch guy, you're pretty much down here in layer 2 and layer 3, right? That's what you're really most concerned about. A little bit of people argue that, well, we go up and down the stack. Whatever, dude. You know what? You're layer 2, layer 3. If you're a route switch guy, that's kind of the primary function of the job. If you're a security geek, you're probably working a lot in here, session and transport side of the house. And then if you're more of a data center type folks, data center folks tend to want to work at the upper layers here. Where does that leave poor old physical layer, right? Still down there by itself, all isolated. I mean, look at some of these drawings here. Look at how nice they are. I even crossed out physical layer down here because, you know, you check it out. It's got this, you know, ugly drop shadow on it and stuff. Down here at the bottom, they got all these really cool arrows showing you how great it is. Even look at this design. It's kind of like, oh, look at all these beautiful colors. I have physical layer. Who knows what that does? And this is probably one of the nicest layer drawings I think I've ever seen, is that it's all really nice and clear until it's all stretched and physical layer, you know, who knows? That's just the data aspect of it, right? But here's the thing. On the physical layer side of its house, this is probably one of the more important ones because, you know, on the end, whatever you're doing up here, all this beautiful code, all these amazing applications that you're writing and stuff, in the end, they all have to be transmitted and understood by physical layer. Physical layer is the one that actually takes all that data and it says, now how in the world am I going to send that across this network? Whether it's a wired network, whether it's wireless, you know, in the open air like this, maybe it's just an interface. Maybe it needs to know, how do I go from a copper interface to a fiber interface, you know? And that's physical layer that actually is the one that determines that those encoding schemes, the ways that I'm actually breaking that data up, data is not this big string of ones and zeros and they're just kind of endless in here. No, man. A computer have no idea where they start and stop. You have to have some type of encoding methodology so it knows where my start point is and then where my end point is. That's why when we're talking about encoding, you'll see it wrote down as stuff like 8B, 10B. So we'll know how to encode that. And every single topology, every single type of interface has its own encoding method so it knows that this is light that I need to send this across, and more importantly, how I'm receiving it back on the other end. Because guess what? Physical layer has to receive it and then start breaking it all apart and start, you know, allowing other places to build that back up so we can actually see it on the screen. No matter if it's this unbelievable, beautiful application or simple telnet session, right? It's physical layer that really makes that happen. Now, the trick is on this is that it gets a little confusing because it is all electrical. It's all based upon voltages of some sort, right? So when we're looking at those voltages, they tend to be incredibly low. Get on another screen here. These voltages on this stuff is typically these ones and zeros that are coming across these lines. These are sent by just a series of basic pulses that are kind of sent up. And those can actually range from like 0.7 volts all the way down to 0.1. So very, very low voltages. I want to show you a kind of cool electrical engineering trick here, is that what makes physical layer so cool. It's the workhorse. It does everything for us, but it has to also be smart enough to know that it can't allow stray voltages. And I mean, look at this studio. I mean, all this stuff lighting up here and stuff, it all has some type of magnetic signature that if we were in here with a magnetometer, we could actually see the resonance field that's actually putting out. That's voltage. That's actually the real deal. It's also voltage if I'm scuffing my feet across the carpet here and stuff, and I go up and, I touch Tony on the ear and zap Ola, I mean, that's that kind of stuff can really trash out equipment. Why? Because physical layer is going to interpret this as a piece of voltage. So that data being so critical, and as a matter of fact, so critical that we actually do things like we call CRC error correction. When you look at how we're looking at reliability, they're always going to go back to CRC because we're doing left and right bit shifting and stuff. We'll cover that in another networking 101 later. But I've got to be able to make sure that when I'm turning something to a 1 or a 0, that's actually what it is, and that equipment, that this physical interface here, this physical interface of being a copper interface versus a fiber interface, they're different. They got a different ground. They got a different way of interpreting that data. So how do I make that work? Electrically speaking, here's what we do. We use a technique that's called galvanic isolation. And what you do, I'm going to draw basically a transformer here. And what you do is that you have this side here and you don't have your electrical components touching, right? And this is very true in physical layer. This is how this works. And so these sides don't touch, so that when this stray voltage comes across, it can't bridge that gap. Let me change colors here because it's kind of an important point. It can't bridge that gap and actually be interpreted as a voltage. We're actually using a magnetic resonance signature here to actually bridge that across. Wah, 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 wah. It's got that cool little Star Wars effect. And you're basically taking that one that's being sent across this network, you're magnetically transferring it across to the other side, and then it's on its way, or to the receiver, to the transmitter, whatever the case may be, so that it moves across. And physical layer does all that stuff, and it does it at lightning speed. All that speed, all that performance, all that technology comes from one place, good old physical layer.